This is DroneX, our drone detection system. I'm Yusuf Basum, the computer engineer student.
I'm Stefan Satzern, electrical engineer student.
I'm Harrison Kennedy, another electrical engineer.
And I'm Nick King, our other electrical engineer.
So our main goal for this project is we wanted to be able to detect drones using machine learning and especially image processing. And we will be discussing how we were able to do that and the components that came in together to be able to detect the drones and also record and watch this live. So for a small demo of our system, this is our DroneX. As you can see, we're connecting it to the power and also connecting it to the internet. But there's also Wi-Fi capabilities coming with it. And this is a live feed from our website, and we'll get into more details just in a second. It's right now it's showing pre-recording. We'll see like the feature that we have and how we implemented it right now. Through our website, you can actually watch a live stream a live stream of what the DroneX is seeing. So as you can see right now, we are actually seeing a drone, and it's a really good precision turnout between 70 and 80, and this is the live stream, and at the same time, it's also recording because since it's detecting a drone, it's also recording, and we'll discuss more about the recording for it in a second. So the model is run on the DroneX, and it's outputting straight to our server, and then we're displaying whatever the stream through the server. And right now it's re-rendering, and it's working live right now. So other than watching live, we can also watch previous detection. So over here we can see all the previous detections that occurred to our system. So right now we are watching this one in particular, and we can see we captured the date, we captured part time, the duration, currently the number of frames, and we can also see the minimum precision and the maximum precision, and how often the drone was visible during that time. So in this over here, you see it's a 20-second video. So the drone was detected for 20 seconds, and one of the main features we have in our system is something called the record manager, and this is one of the engineering specification, and that is that whenever the drone is detected, a timer starts. All right, so that we don't have to check every frame whether a drone is there or not, and we don't have to control, make a decision every second on whether we need to record this or not. We just once we detect a drone, we start a timer. So in our case, we have the timer to be 10 seconds. After that 10-second ends, we check at that time whether there's a drone after 10 seconds. If there's still a drone, then we keep on going and going and going until we don't detect a drone, or um, the maximum size that we can handle is exceeded. So that is one of the main features in our system. That is to first of all increase efficiency on how to on the system, because instead of checking every second, now we can just check every few seconds, and that also removes the problem with YOLO is the inaccuracy and the false positives and false negatives. So that is one of the main things that why this feature is really important in our system.
Specifications, and our three most important, beginning with recording length, a minimum of 10 seconds when a drone is detected. Second is the minimum detection threshold of at least 40% confidence. And last but not least, the latency of the live stream must be less than 90 seconds. And we will demonstrate the first specification later in this demo. Next, we're going to take a look at the hardware block diagram, beginning with the AC to DC power adapter, and this will plug into the wall outlet, and then in turn also plugs into our PCB. The PCB then powers the Jetson Nano, which houses our wireless module. The wireless module utilizes two antennae that stick outside of our system case, And lastly, we have the Pi camera, which has a MIPI connection to the Jetson Nano.
Device, we had two options to choose from, the Jetson Nano Development Board and the Coral Dev Board. We chose to use the Jetson Nano as it had more pin headers and more MIPI connections, allowing for a wider range of development options, as well as it had more online resources, as this is a very popular device utilized by many different projects. The next module we had to consider was the visible spectrum camera. There were two cameras we chose from, the Ecamm Q Nano 30 and the Pi camera V2. The resolution of the Pi camera V2 was 8 megapixels, which is more than double that of the Ecamm 30 Q Nano, and it was less than a quarter of the cost. As well as this, the Ecamm Q Nano had a very tough integration process compared to the Pi camera, which only took about 2 hours to integrate into our system. Because of these reasons, we chose to use the Pi camera. Next, we have our overall PCB schematic of the entire board. The overall schematic for our board includes every component we plan to use in our development. It has the MCU, a cellular module which broke and is no longer functional, and many components associated with that cellular module. It also has 3 regulators, a 5-volt regulator, a 3.8-volt regulator, and a 3.3-volt regulator. As can be seen on the board layout, we chose to try to condense the layout as best we could and put all the voltage regulators on the right half side of the board and all the major components on the left half side of the board. This was done for organizational purposes, and we also had a 2-layer ground pour on both sides of the board to make for easier development.
DroneX project was a success as we met the requirement engineer specification. We imposed upon ourselves in the future. We plan to add more functionality to our design. This is an implementation to 3 specification areas we have identified for improvement. The first being to make the device more mobile by integrating a solar and battery power system. Then increase our ability of detecting by improving the model through more training, as well as integrating a camera, a design which has a higher megapixel rating than the one current. And that is a showcase the presentation. Thank you for your watching.